This table is illustrating the largest watersheds on Earth. As you can see, the largest watershed is the Amazon River. The Amazon watershed, it's in South America. It mainly is in Brazil. And just in terms of the area of the Earth that it takes up, it's 6,144,000 square kilometers. So that's an immense area that this river is taking up. Some of the other big ones are the Congo and the Nile. They're both located in Africa. They together are a little more than the total of the Amazon. In North America, we have the Mississippi River. There are some of the other large watersheds that exist around the planet. This diagram, it illustrates an aquifer and how it can be recharged. So aquifers, what they are is they're underground sources of water. They can either be confined or unconfined. Unconfined aquifers, as you can see, they're right underneath just regular ground. And what happens is the aquifer is infiltrated by water through infiltration. So what happens is water seeps down through the ground and it eventually joins up with the aquifer. The unconfined aquifers, they can be harvested, the water can be harvested using a water table well. While a confined aquifer, it's an aquifer that exists under a layer of impermeable rock or clay. So it's a layer of rock that water can't get through. So you can have a unconfined aquifer on top of a confined aquifer, but they'd be separated by an impermeable rock layer. So that's this rock layer right here. In terms of just like recharging an aquifer, recharge refers to the acquisition of water into an aquifer. So in an unconfined aquifer, just any water that hits the ground will eventually either run off into a lake, river, or stream. And if it doesn't run off into a lake, river, or stream, it will seep through the ground and it will eventually join up with that unconfined aquifer. Confined aquifers, however, they have specific places for confined aquifer recharge, and these can be located very far away from the actual location of the aquifer. So even though I could harvest water from the aquifer over here, the recharge area is located over here. And what it is permeable, allows for the water to permeate the ground that will end up underneath the impermeable rock layer. So that's what allows these confined aquifers to recharge. And in confined aquifer, the way that you harvest the water from it is using an artesian well. Just in terms of water use and resource problems, here is an example of obviously a water use problem gone bad. This is a picture of an abandoned ship in Kazakhstan, and what happened that this ship ended up in the middle of the desert is literally there used to be a large body of water in this area and it all dried up. So obviously the ship that was there, it ended up not having any more water to float on. Major water use and resource problems mainly fall into three different categories. Those are having too much water. Obviously too much of anything can be a bad thing. Having too little water, so if you don't have enough water to keep yourself hydrated, that will obviously produce some problems. And then the other is poor quality or contaminated water. That would be the water that has those different disease agents in it. So on to the issue of too little water today. This is a quote from the World Water Vision Report, and it says, "There is a water crisis today, but the crisis is not having too little water to satisfy our needs. It is a crisis of managing water so badly that billions of people and the environment suffer badly." So what they're trying to say in this quote is basically that there's enough water on the planet for everyone. However, we manage it so poorly that billions of people are affected by it and it causes negative problems. On to the issue of too much water. Too much water usually results in what we would call flooding. So that's when an area is saturated by water. And it's caused by removing vegetation and constructing buildings. So all these things, they increase the potential for flooding on a floodplain. So forests help to reduce flooding through absorbing moisture. As you should know, having vegetation in an area increases the amount of water that that area can hold. That's because these plants, they soak up water. If there's no vegetation in an area, obviously there will be less ability for plants to soak up that water, and in response to that, it will be more susceptible to flooding. So this is an illustration of what happens to precipitation in an urban area. And in an urban area, total amount of precipitation, 25% of the water is either evaporated or transpired back into the atmosphere. 32% of it ends up as groundwater, and 43% of it ends up as surface runoff. So what that is water that isn't absorbed through vegetation or hooking up with groundwater sources like confined and unconfined aquifers. That water is just on the surface, and it will eventually migrate towards a larger body of water. However, during that time, it can increase the likelihood of a flood because in areas that aren't developed, the amount of surface runoff is substantially decreased. In terms of flood management, here's an illustration of one of two different methods of making levees. This is referred to as channelization. And what happens is, in order to build around a river, they'll oftentimes straighten out the river. They'll form it into a channel. So notice that this river is flowing in a straight line. Most rivers don't naturally flow in straight lines. They do what is called meandering, which is just a shape similar to the mouse is making right here, where it just curves the entire time. And in channelization, you straighten out your river, and then once it's essentially in a line, you build up these high levees. And what the hope is that if there ever is a large amount of water, say you have a snow melt that happens on a mountain, and all this snow that's melted, it needs to go somewhere, so it joins up with the river and it raises the level of the river. The hope is that the amount that it goes up isn't enough that the water would spill over the levees and enter the floodplain and possibly flood all these houses. This is how floods were managed in the past. Now we do something that's a lot more natural, and that is introduction of levees into a natural river. So notice this river, it wasn't straightened out, it wasn't channelized, it was allowed to continue to flow in its natural flow and meander. Notice how it's curving. And what happens is you have smaller levees that are a little bit further apart. On the previous one, they were really close to that river. Here, they're much more, there's much more space for the river. And what happens is, as you have that snow melt, where all the snow melts on a mountain, and it's all forced to join up at a river at one specific time, as the river starts to flood, instead of just having the levees there, the whole area that is in between these levees is allowed to go up slowly as opposed to just that specific spot. And as a result, what happens is it's less likely that the levees will be breached and those areas, those residential areas, will be flooded. Too little water is also a major problem in that it can be brought about through droughts. A drought is a prolonged period of time without precipitation. So if an area doesn't experience rain for a really long time, obviously the amount of water that's available will go down. Overdrawing of surface waters, so as we take water from our lakes, rivers, and streams, if the amount that we're taking is more than the amount that they're allowed to recharge or refill, then obviously those surface waters will be depleting, they'll be going down. The other obvious one is aquifer depletion, so the depletion of groundwater. And what that does is it can lead to saltwater intrusion and subsidence. I'm going to talk about those later. This is a world map. What it is it's illustrating areas of water stress. So as you can see, areas in Africa, the Middle East, as well as parts of Asia, they're under very high water stress. We're here as well in some parts of North America, but as a whole, many places remain unstressed. However, it isn't something that's universally happening across the board. In those areas where there is a large degree of water stress, that is where a lot of problems are occurring just due to lack of water or lack of clean available water. Now on to saltwater intrusion. Normally what happens when we have an aquifer, especially when it's near an ocean, there'll be some sort of fresh water that is near the well. And fresh water, it's less dense than brackish waters, which are a combination of fresh and salt water, or salt water. Because they're less dense, they'll be found in the closer to the surface. So when you're pumping water from your well, the thing that you end up pumping is that less dense fresh water out of the well as opposed to the more dense salt water. However, as these levels of water go down, as you overdraw your aquifer, what ends up happening is eventually the water table, the fresh water, will go down, it will get depleted, and eventually what will happen is instead of your well drawing up fresh water, it will eventually get to the point that it's lowered the fresh water so much that instead of getting fresh water, you get salt water because we've gone past the point where it's pumping out that fresh water. As that fresh water gets more shallow, it starts pumping out the salt water instead. So that's called saltwater intrusion. When you've overdrawn your well aquifer to the point that instead of getting fresh water, you're getting salt water. This map is just showing an average annual precipitation for North America. As you can see, some of the areas of high precipitation are located here. That's where our temperate rainforests are located on the west coast near Washington and up the coast of Canada and into Alaska. Other parts of the United States that have large amounts of annual precipitation are over here on the east side of the United States. Here into the plains as well as the mountain region, this is where the Rocky Mountains are located, you're going to have a decrease in precipitation. And as we get a little bit south, getting into the deserts that are located in Arizona and New Mexico and Nevada, the precipitation is going down in those areas. So where you are determines the amount of precipitation that you'll be experiencing on an annual basis. Some water problems here in the U.S. include water issues related to surface waters. Some examples of those would be Mono Lake. And Mono Lake is located in California, and it's a large freshwater lake. What we talked about earlier is even freshwater has small amounts of salt in it. And what happened is this freshwater lake was really controlled by snowmelt. So as snow melted, it joined up with the lake, and throughout the course of the year, the water in the lake would evaporate. And this relationship of gaining water and then losing water would keep the level of salt in the water relatively the same year to year. However, as people started drawing water from the lake, specifically the city of Los Angeles started drawing massive amounts of water from the lake started losing water because with the additional output of providing the city with water, the total amount of water went down. Because the amount of water was going down, but the amount of salt was staying the same, what ended up happening is that the lake became more and more concentrated with salts. And as it became more and more concentrated, it started becoming more like salt water as opposed to fresh water. As a result, many of the organisms that lived there started experiencing problems related to the changing in the chemistry of the water.